Hello, my name is Jorge Emanuel. In this first section, I will briefly review our experience with medical waste incineration. There has been a dramatic decline in the number of medical waste incinerators in the United States, due in part to community opposition and the opposition of environmental groups, as well as a result of more stringent environmental regulations. Communities and regulators have had good reason for being concerned. Medical waste incinerators emit a wide range of toxic air pollutants. Toxic metals such as mercury, lead, and cadmium, acid gases such as hydrogen chloride, toxic organic compounds such as dioxins and furans, as well as benzene, polynuclear aromatic hydrocarbons, and others. Carbon monoxide is also released from incinerators, and also small particulates which, when inhaled, go deep into the lungs. We also know that exposure to incinerator emissions have been associated with an increased risk of various health problems. Studies have shown that people living near incinerators or workers in incinerator plants have higher levels of mercury in their hair or higher levels of lead and cadmium in the blood. Studies have also shown that people living near incinerators or incinerator workers have an increased risk of various types of cancers, such as cancer of the larynx, cancer of the stomach, and lung cancer. There have also been studies that show that mothers living near incinerators have an increased risk of birth defects. These and other studies validate the concerns that the public has about medical waste incineration. Incineration was the most common method for the treatment of medical waste through most of this century until the 1990s. Today, however, we know that medical waste incineration is a major source of mercury and dioxins in the global environment. As a result, there's been a shift to cleaner technologies such as autoclaves or microwaves or dry heat systems. Lately, there have been increasing numbers of proposals for high temperature systems known as pyrolysis or gasification technologies. These technologies are being proposed for applications in municipal solid waste, hazardous waste, and medical waste. There have also been situations where incinerators have been renamed pyrolysis systems and have been sold to countries or cities that have banned incineration or that have placed moratoria on incineration. For this reason, it's important for us to understand what pyrolysis and gasification mean, to explore the environmental issues related to them, and to ensure that we do not repeat the problems that have arisen as a result of incineration in the last so many decades. In this next section, I will review the basic concepts of pyrolysis and gasification. It's important for us to know how these technologies work for us to be able to understand environmental and other issues associated with them. We will see how some of these technologies are virtually identical or similar to incineration, and others have aspects in their design that raise similar environmental concerns as they do with incineration. Let's begin with incineration. Incineration is the rapid thermal decomposition of material by oxidation, in other words, combustion or burning with air or oxygen. Let us take cellulose as an example. Cellulose, represented in simplified form as C6H10O5, is a constituent of paper, cotton swabs, cotton fabrics, and other materials made from plants. This equation means that as cellulose is heated up, that's what the triangle at the bottom of the equation means, heated up in the presence of oxygen or air, and as the temperature reaches about 450 degrees Fahrenheit, which is the ignition point of cellulose, a rapid reaction takes place wherein 1 mole of cellulose, now a mole is just a measure of the number of molecules, 1 mole of cellulose reacts with 6 moles of oxygen to form 6 moles of carbon dioxide and 5 moles of water while liberating heat. We say that combustion is exothermic, meaning it generates heat and can therefore be self-sustaining. But we know that complete combustion does not really happen inside an incinerator. In reality, incinerators produce products of incomplete combustion, such as carbon monoxide or ash. Moreover, waste is not pure cellulose. A typical waste would have heavy metals, it would contain non-combustible substances. It would also contain compounds that have a lot of chlorine or fluorine in them. And as a result, the reactions that take place inside an incinerator are very complicated, and they produce toxic byproducts. And it is these toxic byproducts, such as metals that are released and dioxins and furans, that are then emitted into the air from the stack of the incinerator. Note that incineration can be done in three ways. You could burn the material with just the amount of oxygen needed under the idealized reaction of theoretical complete combustion. This is called stoichiometric combustion. For example, ensuring that there are about 6 moles of oxygen for every mole of cellulose burnt is incineration at stoichiometric conditions. You can also burn with less oxygen than that needed for theoretical complete combustion. This is what's called substoichiometric combustion or starved air combustion. Or you could burn with more air than that theoretically needed. This is what's called excess air combustion.